So hi everyone, I'm Marina. I work at a place called Adara, which builds a hardened runtime for containers. And more importantly for today, I'm also one of the co-chairs of the CNCF's Tag Security and Compliance. Can you hear me in the back? Good? Okay, cool. Sorry. So the tags, or the technical advisory groups, help support all CNCF projects in different specialty areas. So we focus a lot on security and compliance. And one of the areas that kind of brought me to that group originally is software supply chain security. So I'm here today to give you what I'm calling a reality check, or kind of a status report on how we in the community and also just kind of in this industry are doing with software supply chain. So in case you haven't heard of this term before, what is the software supply chain? Software supply chain is the components, libraries, tools, and processes used to develop, build, and publish a software artifact. This is a definition I like from Wikipedia. There's a lot of definitions out there, but basically it's the process from when engineers actually write the code to when people actually use the code on their systems in production, for fun, whatever they're using them for. And why are people talking so much about this software supply chain? This includes things like the source repository security. So where the code is actually stored, who has access to that, all of that. Includes maintainers, and it includes occasionally malicious maintainers. There's been some attacks that people may have heard of where some of the maintainers of a project decide to do weird things to the project. This includes things like build systems and CI/CD. So how the code actually goes from code that we humans can read to like machine readable code, and what happens during that translation process is a really big deal. This includes package managers, where the code is stored after it's built before you download it. How is it? Is it signed? Do you actually verify the signatures? Is it an old version? All of that. Secure software distribution, related to package managers, but kind of more broadly, right? How software actually gets to the people who use it. And also, of course, dependencies. So your software uses other software. We have this whole amazing open source ecosystem of software that everybody is using. But how do we actually keep track of what version of all that software is happening, what CVs have happened in all of those different dependencies, and so on. This kind of all fits under the umbrella of the software supply chain and kind of software supply chain security. So if you've heard of any of these types of things, this is kind of what we're talking about. Oh, and of course, provenance. That one comes up a lot as well. So I'm going to go with a brief history of kind of why we're talking so much about software supply chain security. I think that the kind of attention, the broader attention to this area started around 2020, and there's another attack in 2021 that one could also cite, with the Sunburst attack. This was an attack on SolarWinds, which is specifically SolarWinds Orion software that impacted thousands of organizations, including notably the US government. And what happened was there was a maintainer's some specific credentials were compromised, which ended up compromising the build system. So a malicious version of the software was sent to all of these different organizations. This was like a huge coordinated multi-year attack where this malicious version of the software was in use for a long time before it was actually detected. So it had a huge impact on all of these groups. And this kind of, I think, woke people up to the idea that, there's this build system that's in between you and the software, and stuff can go wrong kind of throughout this whole process. Of course, there'd been research and other things happening before this, but I think this is one of the big moments there. And why are we still talking about it is, there's attacks even today. I think this is one of the more recent big ones. It's kind of still ongoing. There have been multiple waves of this attack over the past several months. And it's a very clever attack, actually. So it's on, if you have the GitHub Actions, can have this pull request target type of action. And a misconfigured type of that action has permissions that I think a lot of people don't understand that it has, which basically allows any pull request to have permissions in the base repository. And the attackers are able to use this to get initial access, and then it's like a software worm, right? And so what it does is it then harvests NPM credentials, uses that to upload malicious versions of packages to NPM, and uses those to get more credentials. So it has this kind of huge spreading attack. And we've seen this happen a bunch of different times, with hundreds, maybe even thousands of packages compromised in total from this attack. And this one's happening last year and into this year. So obviously this is still a problem. We haven't solved it, despite all of the attention. But we have made a lot of progress. And so I want to start by talking about all the stuff that has been done with this big industry and community attention on software supply chain security. The first and most important thing, I think, is increased awareness of software supply chain security and just kind of a knowledge that this is a place that attacks can come from, right? It's not just bugs in the software, it's actually bugs in the process that can also cause these kinds of attacks. Better support for build systems. I think build systems in particular, maybe because of that attack in 2020, are one of the areas that I think have seen a lot of growth and improvement. The SALSA project, Secure Levels for Software Artifacts, I think it's what it stands for. They've done a great job kind of standardizing and creating guidelines for how to do secure builds better. SBOMs and attestations for software provenance. SBOMs, I think, is another huge kind of success story of this, this time of discussion of software supply chain security. An SBOM basically helps you list what artifacts go into your software. And this, especially along with attestations that actually kind of provide provenance information for where that comes from, can help you know what's going into your software. As we saw in several of these attacks on NPM systems, well, the first problem you have when there's attack is to know, so there's this package, this really popular package that was attacked. Do we actually use that? And it was surprisingly hard, I think, for people to answer that question. To actually look at their huge code base of all these different projects and figure out, okay, what software do we actually use? Where is it in our system? And how can we make sure that it's patched? So SBOMs are a really big step in that direction to making sure that we actually know what's happening inside of our software supply chain. And finally, there are a bunch of tools that have been created, especially in the community, to kind of track progress of open source projects towards having better posture in software supply chain security. The Scorecards project is a notable one, as well as LFX Insights, which is available to most projects inside the Linux Foundation, and also the OpenSSF Best Practices badge, which like any open source project can like go through a checklist and kind of see how they're doing. Both the project maintainers and contributors can kind of see how the project's doing and see where they can help, but also kind of people consuming the project can see kind of how mature the project is, whether this is something they've been thinking about. So those help a lot. But despite all of this attention, despite all of this stuff that's happening, the attacks have actually been increasing and not decreasing over the past several years. The exact numbers differ, but every report says that year over year, the number of attacks on the software supply chain are going up and not down, which seems like it's moving in the wrong direction. And so why is this happening? Why, despite all of this amazing progress, are the number of attacks still actually increasing? So what I want to talk about next is the remaining gaps. Why is this still happening? The first, I think, most important gap is that we need more education and implementation. All the tools in the world can't help us if we don't actually use them in our projects and in our software supply chain. And I think that there's a lot of things like that pull request target feature that was used in this most recent attack that people just don't understand, right? They're using it in their project because they think it does one thing and they don't realize the other kind of side effects of what it does. And this is, I think, where like the community comes in. I think going back to what Dim said in his talk about the community engine, this is the next step, right? Is bringing the community to this problem and making sure that all this great tooling that people have come up with to solve this problem can actually be used in practice. That being said, there are still improvements that are needed to the tooling. This is another place that we as the community can come together to build that. I read a report recently about different tools for generating SBOMs. And even if you're generating the SBOM like at the same stage of the process, right, there's a few places you can generate SBOMs. You can generate them from the source code during the build process or kind of afterward from scanning. And even if you're doing the same one of those, different tools will give you a different list of dependencies, right? And so there must be some sort of problem in some of them if they're all giving you different lists. And so there's still obviously improvements needed to the actual tooling, both to make it more accurate and also to make it more usable. I think especially in the realm of kind of software provenance and kind of signing attestation world, if people aren't using like your signature, if you're signing the software but no one is verifying it, I would argue that's a tooling problem and not a user problem, right? We need to make sure that the tooling is easy and it's automatic to make sure that stuff is actually being used. Next, we have communicating when vulnerabilities are exploitable. There's been a lot of attention over the past several years to CVEs and to like identifying vulnerabilities in software and patching them. And this is great. This is something that we should keep doing. But not all CVEs are created equal, right? Some CVEs are in some code path that nobody ever runs, in some package that is only used in one little call in your program. And especially if anyone in here is an open source maintainer, all this attention on CVEs is probably great for security, but sometimes a lot of work for project maintainers because you get all these requests to fix some vulnerability and a dependency that is not exploitable in your project. And you have to waste a lot of cycles kind of explaining this to people. The VEX project has made some progress here towards kind of communicating the exploitability, but I think there can be more done to make this like kind of easy and automated for maintainers. So you have these like automated processes. I was talking to some folks in the Kubernetes project about this recently, where they're trying to figure out like, because they have amazing automation in that project. And they're trying to find a way to make this also automated. And I think that'd be an interesting thing to watch, to see if that can be kind of transferred elsewhere. Because, so that maintainers can say once, like, this is not exploitable in our project, and that kind of percolates to all the different places where those VEX documents are kind of shared. And finally, there's like the missing layers of verification and policy. I think this is a big gap throughout a lot of the tooling, kind of in all those different stages, from source code on up. There's a lot of focus on signing, but less focus on kind of verification. And what does a signature actually mean? This is kind of one of my supply chain security pet peeves, is when someone says, well, it's signed. Sure. How do you know what key it should have been signed with? How do you know people are actually verifying it? How do they know over time that this is the correct version of the software? And I think this is actually in some ways the harder part than just signing it. Signing it is some math. The verification and the policy takes more of this kind of community effort and kind of building this whole thing together. It's kind of the end user tooling and also the understanding of policy, and like it being signed is not sufficient. It has to be signed by the correct person for the correct reasons in a way that like makes sense for you and your project. So I know we're a little short on time, but I think we have time for this. I want to do an exercise together with all of you in the spirit of kind of community and open source. So I want all of you to think of some open source project. Maybe it's a project you maintain, maybe it's a project you use, maybe just something you're a fan of. So I'm going to give you all a second to think of some open source project for this exercise. And I was going to have you do this live, but I know we're short on time, so maybe you can take a picture and do this after. But I want you to do two things for your open source project. I want you to go to, especially if it's in GitHub, the first one's for GitHub. These are particularly for GitHub projects, but so go to the project repository, go to the .github folder, go to the workloads folder inside that, look through all the workloads, see if you're using this pull request target, or see if whatever the project is using it. And please just stop using it. There are ways to use it correctly. They're really hard to do. Instead, just replace it with the workload run and pull request. So the challenge here is that pull request target, it runs on pull requests in the repository, and it runs with permissions of the repository and not with the permissions of the pull request. And so this has caused that most recent bug, as well as a lot of other bugs that allow for credential harvesting of your build system credentials by random people opening a pull request in the repository. Workflow run has less permissions, but can operate on pull requests safely, and pull request has more permissions, and you can use that one safely, but it sandboxes it properly. So yes, please look at that. Let's just eliminate this bug, please. Next, we have, if you are a maintainer, this one's for maintainers only, I'm sorry. Go to settings, in your project, go to settings, action general, and require approval for first-time or external contributors for pull request runs. This makes sure that, kind of related to the previous thing, anything that happens automatically on a pull request can only be done by people you approve. You can't do like Bitcoin mining just by opening a pull request on an open source repository. Without this is actually like literally Bitcoin mining has happened on open source projects where people open pull requests and find a way to use the compute from the GitHub actions in order to mine Bitcoin. So let's stop this one too. Please do that. Share the word. Ask your favorite projects if they do this. Yes. Thank you all. And I don't think we have time to do it live, but you should do all of that. So in summary, I think the software supply chain story is, despite the number of attacks and the fact that they keep happening, I think it is a success story for community. The community has come together to build tools to help secure the software supply chain. But now we have to come together to actually apply them and make sure that we don't just have the ability to stop attacks, but we actually stop the attacks from happening. Here are some links. These slides will be posted as well, so you can actually click them. The first few are kind of a somewhat self-plug for some tag security and compliance resources. as well as a technical community group that I run there to talk more about issues in software supply chain, as well as a couple other projects that I mentioned. So thank you all, and I let you all go to lunch.